Handling very large dataset in Power BI can be a daunting task, especially when you're dealing with millions of rows of data. As businesses grow and data becomes more complex, ensuring that your Power BI report remain performant and responsive is critical. The good news is that with the right strategies, you can effectively manage and optimize your Power BI reports even when working with massive datasets. In this video, I'm going to show you some proven techniques to help you achieve this. So if you're interested, keep watching. The first technique to optimize your large dataset in Power BI is to use DirectQuery mode for real-time data needs. Now, when working with large dataset in Power BI, one of the most critical decisions you'll make is choosing the right data connectivity mode. For scenarios where real-time or near real-time data is essential, DirectQuery mode is a powerful solution. Unlike the import mode, which loads data into Power BI memory, DirectQuery allows you to query data directly from the source database. This approach is particularly beneficial when dealing with millions or even billions of rows of data. Now, the big question is, how does DirectQuery works? Now, in DirectQuery mode, Power BI doesn't store data locally. Instead, it sends query to the underlying data source. Every time a user interacts with a report, the report is sending query to the backend database, which can be a SQL database or Azure SQL database or any other supported sources. This means that the data you use in your report is always up to date as it's pulled directly from the source in real time. For example, if you're monitoring live sales transactions or tracking real-time inventory levels, DirectQuery ensures that your report reflects the latest data without the need for manual refreshes. Okay, so now let me show you how you can implement DirectQuery in your Power BI reports. So I have opened up a blank Power BI desktop here, and what I'm going to do is I'm going to import a dataset into this Power BI file. And my data exists in the local instance of the SQL Server. So I'm going to connect this Power BI file with that SQL Server. So in order to do that, I'm going to just click on this SQL Server icon here, or else you can also go to Get Data and click on SQL Server from here. Now, once you click that, it will ask you for server name and database, which is optional. Okay. The server name, if you don't know, when you open up SQL Server Management Studio, and I'll just quickly show you, the server name will be visible on the left side Object Explorer panel. Okay. All you need to do is just right click on this server name, go to properties, and then you can easily copy paste your server name from here onto the server name placeholder on Power BI desktop. So I'm going to place it here. The database name is BI, and obviously the server name for you when you are implementing this would be different because you'll be connecting your Power BI to your local instance of SQL Server or your cloud instance of the database that you're using. Okay. So keep that in mind. This server name will not be same for you. Then in the data connectivity mode, this is where we're going to choose DirectQuery. Okay. Which means instead of importing all the data which is there in our SQL Server, it's going to establish a direct link between this Power BI file and that SQL Server. We also have some advanced options here where you can write specific SQL statements to fetch only the required information. But I'm not going to write any SQL statement right now. I'm just going to click on Set Direct Query and press OK. And this will show you the server and the table which exists within that BI database. So I'm going to choose this powerlifting table that we have. It's a simple table about a powerlifting competition and all the athletes who participated and what were their records. So I'm going to just click on Load. And now we have successfully established a direct query connection between this Power BI file and your SQL Server. Let's create some charts using this. So I'm going to place a name here and let's place total kg in this. The key difference that you would notice when you apply a direct query is that on the left panel, you would not see the table view section. Usually you would have 4 tabs here, right? But then now we only see a report view, model view, and then DAX query view. There is no table view. Now let's see how fast is this approach in terms of usual refreshes. So I'm going to open up the SQL Server environment once more, and within this we have a BI database, and then we have a powerlifting table. I'm going to open up a new query. First of all, let's check this value. So there is a name called A space blank, and then the total is 530. What I'm going to do is I'm going to update that value. So let's say update powerlifting, set total kg is equal to 0, where name is equal to A blank. Okay. Now what it's doing is it's just simply updating the value for A blank to 0. So I'm going to run this code and it says 1 row affected. Now let's see how fast that update gets refreshed here. So I'm going to click on refresh. And if you see, the update has been refreshed and automatically the number has been updated here. It was that fast. Perfect. So now let's move on. The second technique is pre-aggregating your data at the source. Pre-aggregation involves summarizing or consolidating data before it is loaded into Power BI, reducing the volume of the data that needs to be processed and visualized. This technique is particularly useful when working with millions or billions of rows, as it minimizes the computational load on Power BI and ensures faster report rendering. So this is how you can apply a basic level of pre-aggregation on your data. So I'm going to go back to SQL Server again, and within this, as you know, we have this table which is powerlifting. I'm going to create a view on top of this table. Okay, you can also create a table as well, but for now I'm going to create a view. So I'm going to say create view. Let's name this summary, and then inside this I'm going to write a simple SQL statement. Select division and then count of division. From powerlifting and group by division. So what this query is doing is it's creating a view which will be a summary view and giving us the total number of athletes who have participated in each division of the competition. Okay, so I'm going to run this and it says command completed successfully. So I'm going to go to the view section, and if you don't see the new view here, you can just refresh it once more. And now I can see this new view here. I'm going to right click and select top 1000 just to see if the data is coming in properly. Now, as you see, we have the division column and also the athlete count. It's creating a summary of the entire table that we had, which had close to 386,000 records in it. And now we have summarized it into this form. Okay. Now what I'm going to do is I'm going to go back to Power BI. Go to get data again, click on SQL Server, paste in the server name, keep this on DirectQuery, click on OK. And within this, now you see the new view that we created. I'm going to select that and click on load. So now this summary has also been loaded. I can view the new columns that we created. So the division and athlete count. And if I just want to see the total number of divisions that it has created, I'm just going to click on count. And if you see, from those 386 row item, we have now reduced that data to just 4080 rows. Cool, right? Okay, so now let's move on. The third technique is using Dataflows for pre-processing. Power BI offers a very powerful tool for pre-processing, which is Dataflows. Dataflow allows you to clean, transform, and shape your data before it reaches your report and dashboard. By offloading these tasks to Dataflows, you can significantly improve the performance of your Power BI reports. Let me show you how you can implement Dataflows in your projects. For now, I'm going to publish this Power BI report onto the Power BI services because Dataflows work on Power BI services. That's the second part of Power BI that we usually work upon. So the first part is Power BI Desktop and the second part is Power BI Services. Okay. So what I'm going to do is I'm going to publish, and in this, I'm going to select a workspace that I have. Now, remember, in order for you to do this, you need to have at least a pro license, if not a premium. Okay. You would not be able to do this on a free license. So right now I have a pro license. So I'm going to publish onto this workspace, which is tutorial. Okay. So the publish has been done, but it's giving me a prompt. It's saying your file was published, but disconnected. So let me go to this open data settings and show you what's happening. The moment you click on that button, it will take you to Power BI Services, which is app.powerbi.com. The problem here is right now, although we have published our report onto Power BI Services, there is no live link between the cloud platform and the SQL Server database. So next time when we want to refresh this report, and if we try to refresh that report using Power BI Services, that will not work. In order for us to create a link between those two, we need to install something called as a gateway. A gateway acts as a bridge between your on-premise database and the cloud platform. Okay. So now gateways can be installed on your system so that it can create that connection between the services and the database. If you have not already installed the gateway on your system, this is how you do it. You click on this download button, and within this you click on data gateway. This will open up this new page from Microsoft, and within this just click on this download standard mode, because this is what we require. And when you do that, you will get a setup file. Just double click on that setup and follow the instructions. Installing gateway is pretty straightforward. Once you install it, the gateway is there on your system, and now we can use it to build that bridge between cloud and SQL Server. So inside this gateway and cloud connection, you will see this new line item. Now in this line item, this is the gateway that you just installed. Mine says Power BI Tutorials Gateway. You can name it anything you like. So now it says not configured correctly. I'm going to click on this arrow icon here, and within this, I'm going to click on add gateway. Let's give it a connection name. It's asking for a username and password. This is the username and password for your SQL Server, the login details from there. Once you do that, come back to the gateway and cloud connections. And now the gateway has been configured properly. Now you just have to map it. So you'll get this drop down. You can just click on drop down and click on the new gateway connection that you configured and click on apply. So let me try and publish this once more. And now if you see, we are not getting that error regarding the connection. It's simply publishing the version onto Power BI Services. So now I'm going to go to Power BI Services again. Go to the workspace and click on the workspace which has a pro or a premium license. Now the reason I showed you how to install a gateway and apply it is because gateways are essential while you build a data flow. So I'm going to click on this new item here, and within this I'm going to choose Dataflow Gen 1. We also have a Dataflow Gen 2, but this can be used if you have a Fabric license. I right now do not have any Fabric license. I can choose for a free Fabric license, but for now I'm going to just click on Dataflow Gen 1. Okay. And then it's going to give you a prompt. I'm going to say no, create a Dataflow Gen 1. And in this first window, because we are creating a new data flow, you have to click on this first option which says define new table. So I'm going to click on add new tables. Okay, so now from here, you just select the data source. For us, it's SQL Server database. I'm going to click here, enter the server name, give the database name, keep it on create new connection. And now we need to choose data gateway. We already installed one, so we should see that on the drop down. So this is the gateway that we installed. Keep the authentication kind as basic. Enter the username password. Again, the username password for your SQL Server might be different, so put in the credentials accordingly. And now press next. choose the table name and click on transform data. Now, if you notice, this window is similar to your Power Query window in Power BI Desktop, right? And the functionality is pretty much the same. You can do all the activities that you see in Power BI Desktop in here as well. For now, what I'm going to do is I'm going to just keep a couple of columns and remove remaining. Okay, so I'm going to keep these columns, right click and say remove other columns. So now I have these 6 columns with us. So we can do n number of transformation steps on this data set, but I think you get the gist. You can just explore what else is available and apply those steps as per your needs. I'm going to just keep it as it is. And now I'm going to click on save and close. Now you can save your data flow with a given name. And now if you go to your workspace, which was tutorial for me, you will see this new data flow which appears here. Okay. Now, once you've created your transformation step within your data flow, you are ready to use that data flow within your Power BI. Okay. So I'm going to click on this Power BI desktop here. Let's create a new one. And in this, I'm going to choose the data, and from this selection, I'm going to choose data flows. Go to the workspace name, and in the optimized data flow, you'll see the new table that we transformed. And in this, if you notice, we only have those 6 columns. You can either choose transform data or you can just directly load. I'm going to just directly load because all the transformation we've already done in our data flow. Now, once that is done, you'll see that we have this table, and this is directly connected to the Power BI services data flow. Now, if I publish this report, I'll publish it onto the tutorial workspace. Okay, let's go to the Power BI services, refresh, and now you'll see that our report is actually connected to your data flow, not the SQL Server directly. So what will happen is you can set up a refresh schedule, and every time this data flow will fetch information from your SQL Server, apply the transformation onto the new data, and then your report will automatically get updated. Perfect. Let's move on to the next technique. The fourth and the final technique is implementing incremental refresh. Incremental refresh is a feature that allows you to refresh only the most recent or changed data in your dataset rather than refreshing the entire dataset every time. This approach is particularly useful for datasets that grows over time, such as transactional data, logs, or time series data. In this approach, your dataset is divided into smaller manageable chunks based on a specific criteria, such as date range. During each refresh, only the new or modified data is processed, while the historical data remains unchanged. This significantly reduces the time and resources required for data refreshes, making it an ideal solution for large datasets. So now let's see this in action. In order for us to implement incremental refresh on any Power BI file, the dataset that it contains should have a date column of some sort. Okay. So what we're going to do is we're going to use a new dataset here. And in our SQL Server, we have a table which has Apple stock prices in it. Okay, so I'm going to just show you quickly. It contains a date column, it contains volume, and it contains a closing value column. We're going to use this data to implement incremental refresh. Let's open up a new Power BI file. And in this, I'm going to choose SQL Server, paste in the server name. And for now, I'm going to keep it at import mode only. Press OK here. And within this, I'm going to choose that new table, which is AAPL. And instead of loading, I'm going to click on transform data. Now, when you're in the Power Query window, the first step that you need to do before we implement incremental refresh is to create 2 parameters. Okay. So with this, I'm going to click on this manage parameter section here. And in this, I'm going to click on new parameter. Let's create first parameter as range start. And remember, you need to name this parameter exactly this, range start, without any spaces. Otherwise, this approach might not work. Type as date time. And then in the current value, I'm going to put a date. 1st January 2021. Okay. And the date doesn't matter. You just put any value for now. Let's create another one. This one would be range end. Again, type as date time. I'm going to give it another date, 31st December 2021, and press OK. So now we have two parameters here. Now in the main table here, which is AAPL, I'm going to apply a filter on this date column using that parameter. Before you apply that date, just make sure your date column is in a date time format. I'm going to click on this small icon here and change it to date time. Once that is done, click on this drop down, go to date time filters, custom filter, and in this just select after or equal to. In this drop down, select parameter, and the parameter is range start. And then in the second condition, just say is before, again parameter, and in this select range end and press OK, and then click on close and apply. Now let's create a chart from this data and see what's happening right now. So I'm going to choose this date column and closing prices. Let's put it in a chart. Let's expand the date column into months. Now if you see, it's only showing up the values for 1st January till 31st December, because if you remember in the parameters, we have set the value as such. Okay, but this is fine. We are going to use those parameters in our incremental refresh. So I'm going to save this. And now, because I want the incremental refresh to apply on this AAPL dataset here, I'm going to click on this three dots icon here, and within this, click on incremental refresh. Turn on set import and refresh ranges, and let's start assigning few values. Now, when you talk about incremental refresh, it works in two phases. First phase is where the data gets archived, and second phase is which range of data gets refreshed in an incremental fashion. Okay, so I want the first 5 years of data to be archived. So I'm going to write 5 and click on years here. And then incremental refresh data, I want an incremental refresh daily. So I'm going to write 1 and write days. Okay, so if you notice, archiving date starts from the refresh date. So the date when your data is getting refreshed, from that date for the past 5 years, the data is getting archived. The incremental refresh will happen for only the latest day, which is the current date. Okay, the date is also mentioned here. It says data imported from 1/1/2020 till 22 March 2025, and then data will be incrementally refreshed from 23 March to 23 March. Okay, and if you want to just see how this works, this is the entire data, and only this part of the data, which is 1 day, will get incrementally refreshed. So today it will refresh today's data, but tomorrow it will again refresh, but refresh for 24th of March and archive the remaining data. These are some optional settings that you can select. You can leave them as blank for now and apply. And now incremental refresh has been applied on this PBIX file. Let's save this and publish it onto the workspace. Again, go to the open data settings, because this is again giving that same error which says there's no connection between your source and the services. So go to the setting here, go to gateway and cloud connections. This is already configured. We just have to map it. So just click on this drop down, click on SQL Server and apply. The connection has been applied. Go back to your workspace. And if you see, this is the optimized version 3 that we have just published. Now remember, when the first time that you refresh, it will take a longer time because it's segmenting your data as per the rules that we have set. But on a later refreshes, the refresh will be really quick. Okay, so I'm going to refresh it right now. It's going to take some while because right now it's segmenting all the sections that it needs to archive and it needs to refresh. And once the rules are set for the first time, the subsequent refreshes will be very fast. Okay, this is refresh now. Let's try refresh once more. And if you see, it has quickly refreshed, right? I'm going to open up this report. And if you observe, the chart now shows data from 2020 till March 2025. Earlier, the Power BI file that we used was only showing data for Jan 1st, 2020 till December 2020, right? Because of the parameters. But now the incremental refresh used those parameters and altered it as per our rules. So these are the 4 main techniques by which you can optimize your large data set in Power BI. Each of these methods plays a unique role in optimizing your Power BI performance. The key to success lies in understanding your data, identifying the right optimization technique for specific use cases, and following best practices to ensure smooth implementation. So take the time to evaluate your current processes, implement these optimization techniques, and watch your Power BI solution thrive. If this content was helpful, then please consider subscribing to the channel and hit that notification bell icon so that you do not miss any content that I upload. And as always, thank you so much for watching. I'll see you in the next one.